Alright, for the advanced video on converting wind energy into electrical energy, we're going to study the amount of electricity produced in more detail. And to do that, we're going to have to learn some new terms here. One is going to be the voltage, which is the pressure or push on electrons, and the amperage, which is the flow of electrons. If we have a larger flow of electrons, we have more of them. If we multiply the push on the electrons, the volts times the amps, that'll equal the watts. And the watts, the term for that is the power. Okay, and we know about 50-watt light bulb compared to a 100-watt light bulb. 50-watt light bulb is not as bright as the 100. The 100-watt light bulb then is more powerful. We also then can multiply the watts times the seconds, or the amount of time that the power is produced. And in this case, we're going to measure our output for 30 seconds. And that'll give us the total energy amount in joules. All right? Now, to make those measurements, we're going to have to introduce a new piece of equipment here. And this will be the meter board. And what we've done here is we've added we have a voltmeter, which is what we used before, and it's set to 20 volts DC. But now we've also added an amp meter to measure the amps or the flow. And there's a little change here. The common is still in the black, bottom hole, but then we go up to the 10 amp scale because we want direct amperage reading. The units have to be the same. So we're on the 10 amp scale, and we'll read the amps on this meter. We also have introduced a load. This is a 30 ohm resistor. Now, if you study this more, you'll learn that voltmeters have to always be wired in parallel with the source of generator, the power, and the ammeters have to be wired in series with a load to the generator. We've simplified this for you, so all you have to do is hook up the leads to the meters and then take the leads to your generator, and you're in business. So let's turn this on. Let's start the timer once it gets going up to speed. Okay, I'm going to move this back a little, all right. And it's running up to speed. We'll start the timer. And for 30 seconds, now you can see we're getting about 1.8 volts. Fluctuates back and forth a little bit. And 0.05 amps. So now we're going to run that for 30 seconds. And I'm going to jot the data down on our board here. And that's our time, 30 seconds. And we'll shut this off. So what we have is 1.8 volts times 0.05 amps equals 0.09 watts. And we produce that wattage, okay, that amount for 30 seconds. And that will equal 2.7 joules of energy. All right? And now what we want to do with that data is we want to run a second test. So now you're going to take and put someone else's blades on your generator. Let's take the 4-blade one this time. All right. Turn it on. And you're going to collect new data. You're going to collect voltage, and you're going to collect amperage for a 30-second period. Do the calculations, and you'll know if this one is producing more joules than the other 6-blade design. And the one that produces the most joules in 30 seconds against a 30 ohm load is considered to be the best design. And there you have it.